Hi everyone, how's everyone doing today? Welcome to this session. Today we'll go over system integration testing, regression testing, and delve into other topic today. So let's get started. Let's start with system integration testing. System integration testing, or SIT, focuses on verifying the interaction between different modules or systems to ensure they work together as expected. For example, think of different modules as like puzzle pieces. So SIT ensures that all of the pieces fit together perfectly. So what are the steps in system integration testing? First, we test whether the modules interact and connect seamlessly. Once system integration testing is complete, what do we move to next? We move on to the system testing. It evaluates the complete system and focuses on how it performs as a whole. Now, there are different stages of systems testing. So, let me give you a preview. First, the SIT environment. It has two parts. One is system integration testing, and another one is system testing. In system testing, it has different steps like graphics user interface testing, functional testing, non-functional testing, and usability testing. So in graphics user interface testing, it ensures the user interface looks and behaves correctly. The functional testing validates the functionality of the application. The non-functional testing checks different performance, reliability, and their security. And the usability testing evaluates user friendliness and ease of use. Okay. Now, uh, let's talk about regression testing. What is regression testing? So, the regression testing ensures that the recent changes in the code haven't introduced any new bugs or impacted the existing features. There are two types of regression testing. One is full regression, another is sorry, um, full regression, regional regression, and also unit regression. In full regression, it is executed after significant code changes, covering the entire application. The regional regression focuses on testing on specific areas where changes were made. And the unit regression, it usually targets individual modules or features. In system integration testing, full regression is applied during the graphics user interface and functional testing. So it is full regression. If we find the issues, we follow up with regional or unit regression testing. Now let's introduce ourselves to functional testing. Functional testing. Functional testing ensures the application behaves according to the requirements. For example, when you log into the computer, log in the website with username and password fields, they must work perfectly. None of them can have any problem or any sort of issues. There are different types of functional testings, like API testing, database testing, database testing. Then the third one is globalization and localization testing. Now, for API testing, it validates interactions between software systems using APIs. And in database testing, it checks data storage and retrieval process. Okay, now in globalization and localization testing, the globalization ensures adaptability for multiple regions and languages, whereas the localization tailors the application for a specific region. Imagine testing a calculator. We validate addition, subtraction, and other operations during calculation testing. Whereas the manipulation testing would involve ensure data input is processed and displayed correctly. Now let's go to non-functional testing. In non-functional testing, it focuses on the application's performance, reliability, and security. It ensures the app works well under different conditions. Now, like functional testing, the non-functional testing also has some types like performance testing, security testing, compatibility testing, and reliability testing. In performance testing, it checks responsiveness, speed, and scalability under load. For example, it will check, can an app handle 10,000 users at the same time? In security testing, it identifies vulnerabilities to prevent unauthorized access. Ethical hackers simulate attacks to find weak joints, performing penetration testing. In compatibility testing, it ensures the application works across browsers, devices, and operating systems. For example, you can take like testing on Chrome, Firefox, and Safari, etc. And for the last one, the reliability testing, it assesses whether the app runs without interruptions under normal conditions, like testing for stability after several hours of use. Now, the next step is code movement process. Code movement process. After developers make changes based on feedback, the updated code moves through various stages. Like the code is committed to GitHub, then it deployed into the SIP environment, then it moves on to UAT. In UAT or user acceptance testing, it involves testing by business users to ensure the application meets their expectations. Feedback from UAT guides final adjustment. After UAT, it goes to production. In production, the final build is deployed for production, where the app is accessible to end users. Now, usability testing. Usability testing ensures the application is easy to use and intuitive. It's often conducted by an external team acting as end users. Here, external testers interact with the application, then they provide feedback on design, navigation, and overall experience, and the developers make changes based on the recommendation. So the difference between usability and beta testing is beta testing involves releasing the app to a specific group of users before public launch. Whereas usability testing focuses on user experience improvement during the development. So till now we can say that the system seat integrates modules and tests their interaction. The regression testing ensures changes don't break the system. The functional testing verifies features and non-functional testing evaluates performance and security. The usability testing ensures user friendliness. Now let's talk about the beta testing. So if the beta testing is where the application uh, is shared with a selective group of external users before the official release. These are end users, often representing the target audience of the product. Then the feedback collected from beta testers help improve the product before its launch. So there are two approaches for beta testing. One is step one is business people test the app, and step two, the end users provide feedback. So in step one, the business people test the application. Here, in the initial phase, the business stakeholders test the application by running business test cases. These test cases are designed to confirm if the product meets expected business outcomes, such as profit margins or revenue goals. For example, let's say the product is an e-commerce app. The business team checks if the order, payment, and profit calculation system works as intended. In the second step, end users providing feedback. After the business test, the product is handed over to the selected beta tester. These testers are real users carefully chosen to provide feedback on usability, functionality, and overall experience. So the outcome from beta testings are the feedback from beta testers is gathered and used to make necessary adjustments before moving on to the next step. So let's draw you a diagram to make you easy to get to understand. Here is the developer, it is the product, it is deployed into GitHub. After that, it generates a URL link. So it goes to alpha testing. Here we talked about beta testing. It is tested by business people. Okay. Now user acceptance testing. UAT. UAT or user acceptance testing is performed to validate the application from a business perspective. At this stage, users refer specifically to the business stakeholders or client. Why is it called UAT? It's called user acceptance testing because the business stakeholders directly test the product to verify if it meets their needs or expectations. It is also known as client acceptance testing. Mhm. Acceptance testing. In some organizations. Keep this term in mind as the terminology might vary from company to company. So UAT takes place in a dedicated UAT environment Okay, so once the business team is satisfied with the result, the application moves forward. Think of UAT as the final checkpoint for business stakeholders before the product is handed over to the end user. Now let's talk about pre-production stage. After UAT, feedback is reviewed and developers make necessary changes to the code base. This phase doesn't involve major modifications since the product is almost ready. So the developers make minor tweaks to fine-tune the application. What is pre-production? Pre-production is the staging ground where the product is prepared for its official release. The primary focus here is on final testing, ensuring everything works perfectly. The pre-production is a staging area. So what is a staging area? In pre-production stage, some organizations have separate environment called the staging area. In staging environment, final round of testing, especially performance, security, are conducted. So here, performance, security is conducted. So why focus on performance and security? The staging area is the last opportunity to test the product before the release. We verify the product in this phase. In performance testing, how does the application handle load and stress? Can it manage thousands of users simultaneously? And in security testing, are there any vulnerabilities? Can unauthorized access be prevented, etc.? This. Then comes regression testing. So after this comes regression testing. Once the changes are made, full regression testing is conducted to ensure no new bugs were introduced. The regression means repeating tests to verify the application works as intended after updates. A regression suite contains a collection of test cases focused on essential features. Think of it as an Excel file where all test cases for regression testing are grouped together. Then the automation suites. In pre-production, testers often use automation suites for efficiency. And automation suites allow you to run tests continuously with minimal manual intervention. You click one button and it runs for hours. Then for the final steps before production, after the pre-production is completed, the product is deemed stable and is ready for pre-release. Sorry, it's ready for release. Critical functionalities are retested to ensure that no critical issues remain. In production release, the product is deployed to the production environment, making it available to all users. Now imagine for a moment I'm working on Facebook. Currently, the version available at market, the one being used by millions of users, is 10.5.600. Let's call it a stable version. So it's a stable version. This is the live version people see when they open their app or browser. Now, behind the scenes in the company's repository, say GitHub, there's an older version which is 10.4.500. This version that was live previously but has been replaced by the current stable version. So it's an old version. So why do we keep this? Because it's part of the history of the application and developers might still need it to refer for debugging or comparison. Finally, there's an upcoming update in version. Let's call it 10.6.615. So it is the update. This version has new features and improvements, but there's a catch. It hasn't been released to the public yet. It's currently in the beta phase, meaning it's not stable for the end users and still undergoing rigorous testing and validation. So, why do we even release new versions? New versions are released to introduce new features, fix bugs, or improve the overall performance of the app. For example, let's say we added a new feature that allows flight booking within Facebook, an entirely new functionality. That's exciting, right? But it requires significant development effort to ensure it integrates seamless with the existing features. Now, how long do you think developers take to build a single feature? It's not an overnight task. Typically, creating and testing a feature can take around between seven to 12 months for more complex functionalities. So, what does that mean if we say a beta version? A beta version is not a stable version. Even though it's functional and it includes all the new features, it still needs more testing. Developers and testers use this phase to identify bugs and refine the app. Beta version often relies on feedback from selected users who are part of the beta testing process. So, what's the benefit of being a beta tester? A beta tester uh, benefits of beta tester. A beta tester gets early access to the latest features long before they are released to the public. They can provide valuable feedback, suggesting changes or improvements that can make the app better. However, there is no profit. They don't gain anything. It's more about contributing to the app's development and being part of the innovation process. But remember, beta versions can still have bugs. That's why they are not released to everyone. The goal is to address this bug and make the app reliable for the public, what we call the stable version. Now let's go a bit deeper to the testing phase. Once the beta version is released, it undergoes user acceptance testing. Here, the business stakeholders and clients test the app to ensure it meets their requirement. If they approve it, the version moves to the pre-production stage, where additional fine-tuning happens. Okay? Now here's something important. Testing doesn't end here. In pre-production stage, developers and testers run performance testing, security testing, and sometimes even ad hoc testing. So let me explain. In performance testing, it ensures that can handle high traffic loads without breaking down. In security testing, it protects sensitive user data from breaches and vulnerabilities. And in ad hoc testing, this is the more of an informal testing approach, where testers randomly check various functionalities to catch unexpected issues. When it's time to deploy the new version, the app enters what we call a maintenance window. Okay. Mm, so, mm, During this time, the current live version is temporarily taken offline so the new version can be installed. Have you ever visited a website or app and seen messages like page not or like maintenance in progress, etc.? That's the maintenance window in action. This maintenance window typically lasts for 5 to 6 hours, depending on the complexity of the update. Here's what happened during the period. The existing live app is removed from the servers. The updated version is installed. Testers run quick checks to ensure everything is functioning as expected. For example, if it's a flight booking features being added, testers will verify the booking process works perfectly. But they'll also check if other functionalities like uploading photos are still working. This ensures that the new feature hasn't accidentally broken anything. After deployment, the app enters the staging environment, where the real world performance and security tests are conducted. You can ask me why. Because once the app is live, it will face real traffic. Thousands, even millions of users accessing it simultaneously. If the app can handle this load, it might crash. For instance, let's say that the new flight booking feature works fine, but uploading profile pictures suddenly stops working. That's a major issue, and it's exactly what the staging test tend to catch before the public release. Finally, once all tests are complete and app is confirmed stable, it's released to public. The new version goes live and the maintenance window closes. At this point, the app is officially available for everyone to use, with all of its new features intact and functioning perfectly. So, from the initial development of a new feature to its testing, deployment, and eventual release, this is the journey every app version takes. It's a meticulous process, but every step ensures the app remains reliable, secure, and user-friendly. If you have any questions till now, you can ask. Now imagine this scenario. A new version of an app is ready to be deployed. The current version is already live in the market, which means the application is in production. Now, this is where the challenge begins. How do we ensure that the new version is stable without taking too much time? After all, in a production environment, time is critical, and we can't afford to spend hours testing each and every single feature. That's why certain test types like ad hoc testing is crucial. Let's understand the context a bit more. In production, the app is already live, which means we have limited uh, time during the maintenance window. So typically, the maintenance window lasts for 5 to 6 hours, during which the app might go offline and experience reduced functionality. So for the deployment time, approximately 2 hours is needed for replacing the existing version with the new one. And for the testing, it is usually needed 1 to 2 hours to validate the main functionalities. As you can see, this doesn't leave us with enough time to run a complete set of series tests, which would typically include regression testing, performance testing, and more. So instead of testing everything, we focus on the essential functionalities, the areas of the app that are more critical to its operation. This target testing approach helps avoid potential breakdown. This is where ad hoc testing comes into play. It is a type of manual testing where testers focus on main functionalities of the app without relying on detailed documentation on or pre-written test case. So it is for main function. So it is effective because for once no documentation is required. Unlike traditional testing methods, ad hoc testing doesn't require you to follow any structured plan. This saves time when quick validations are needed. And target testing. Testers focus on areas that are more likely to fail based on their knowledge of the app's weakness. For example, imagine a social media app where a new feature like a flight booking service is being added. In ad hoc testing, testers might check if the flight booking process works without errors. Other existing functionalities like posting updates or uploading photos are unaffected. The goal is to ensure the core features work as expected and to catch any major issues that could cause a massive breakdown. But what happens when things go wrong? What if the new version causes severe issues after deploy? In such case, it's essential to have a previous stable version. Let's call it a fallback version. This is why companies often maintain a backup of the stable version in the pre-production stage. For instance, if the new version starts crashing immediately after deployment, the fallback version can quickly restore the uh, website to ensure users don't experience prolonged downtime. Keeping a fallback version ready helps protect the business reputation and avoids revenue loss. Now let's discuss two important testing approaches: fall forward testing and fallback testing. Fallback and fall forward. These two type of testing is performed in fall forward. It's performed on the new version to validate that the updates and new features are working as expected. The goal of the fall forward is to check if the changes have been implemented correctly without introducing new issues. For example, if the new feature of a set of emojis, fall forward testing would ensure that these emojis work correctly and don't disrupt the existing feature. And in the fallback testing, it focuses on the previously stable version. It ensures that the case of failure, mm, the system can safely return to its previous state without any adverse effect. For example, if the new version causes problems, fallback testing ensures that rolling back to the previous version will work seamlessly. Together, these two approaches help mitigate risks during deployment. Fall forward testing validates the upgrades, while fallback testing ensures that there is a reliable data flow. Now let's talk about control production environment. Now let's address the critical point, the difference between control environment and the production environment. In control environments, it includes uh, development, seed of system integration testing, and staging environment. These are isolated setups where testers can use mock data or dummy data to verify the app's functionality without affecting real users. And in the production environment, it is the live version of the app which is used by the actual users. During pre-production, we perform tests like full regression testing in a controlled environment. This involves testing the new version inside out to ensure all features are functioning correctly. However, once the app is in production, time constraints make it impossible to repeat this exhaustive tests. In production environment, we rely heavily on ad hoc testing because it's quick and focuses on weak points of the app, areas that are more prone to failure. It also doesn't require test cases or documentation, which speeds up the process. It's highly manual, allowing testers to use their experience to identify potential risks. For example, testers might manually test the logic functionality, payment gateway, or other critical features that users rely on daily. The aim is to quickly identify and fix issues before the new version is fully released. Now, final deployment. So, uh, in the final deployment steps, we learned that in pre-production stage, they perform full regression testing on the new version, ensure the fallback version is ready in case of issues. Then the deployment in production where opening the maintenance window, installing the new version and run quick tests. and the post-deployment testing, where it uses ad hoc testing to validate essential features. It conducts fallback testing if necessary to ensure the previous version can be restored smoothly. By following this process, we ensure that the deployment is as smooth and risk-free as possible. Now, in the world of testing and development, understanding the types of data used is fundamental. Now, let's discuss three key data types. One is mock data, the other one is real data, then synthetic data. So, what is mock data? It refers to fake data prepared by the developer. It is primarily used in development and staging environment. The purpose of mock data is to simulate scenarios and test functionalities without requiring real or sensitive views. The real data is actual user-generated data collected from the end users. It reflects how the application is being used in real-world scenarios. This data is crucial for validating the system post-production. Now, for synthetic data, it is usually an artificial generated data that replicates the properties of real data. It is similar to real data in structure, mhm, and usage, but isn't derived from the actual user input. It is created using specialized software. Synthetic data is often employed during testing to mimic the real world scenarios without risking exposure to sensitive information. Now, the purpose of synthetic data is vital during pre-production and testing stage. It helps simulate real-life experience while safeguarding privacy and adhering to compliance requirements. Specialized software tools generate synthetic data by following patterns and behaviors seen in real data. Now let's move on to what happens in production environment. Production environment. So mm, in production environment, before the deployment, a maintenance window is scheduled to ensure the minimal disruption of users. Okay. Then uh, eh, it is preparatory steps including setting up the environment, verifying dependencies, and planning the rollout process happens. for deployment. Then quick informal testing is performed to check the basic functions of the application, which is the ad hoc. Purpose is to identify any glaring issues or defects before the release. Then the performance, security, and stability testing is conducted uh, so that the application is met with quality standard. Then once deployed, the DevOps team closely monitors the applications. They address any issues, optimize performance, and ensure smooth operation. And in IT, we don't say the product is in the market. Instead, we say it's live. Live means the product is available and is ready to use, which falls on the terminology. So the goal of the ad hoc testing is to find bugs by targeting weak points in the application. For example, if you have been working on an application for a long time, you know its weak points. Ad hoc testing involves deliberately triggering this weakness to assess the stability. Now, let's talk about monkey testing and gorilla testing. Monkey and gorilla testing are exploratory methods for testing. In monkey testing, it is a random test where the application is used without any predefined scenarios or knowledge. Its purpose is to trigger unexpected behavior and test the application's stability. So imagine giving a phone to a toddler. They type, swipe, and randomly interact with the screen. This unpredictability simulates monkey testing. So here no prior testing knowledge is required. No documentation is followed and take place before or after production. Then comes gorilla testing. Gorilla testing is a more focused version of monkey testing where one module or component is tested rigorously or repeatedly. Its purpose is to ensure the stability of a specific feature or module under intensive stress. Now let's talk about exploratory testing. Testers explore the application to understand its features and behavior. It doesn't require any prior knowledge or documentation. The purpose of exploratory testing is to check functionalities and discover new features or potential issues. For example, when end users interact with a new application for the first time, they effectively perform exploratory testing. So when the issues are found, they report them to the Scrum Master during the daily stand-up meetings. Now, let's understand the difference between SDLC versus STLC. SDLC is the software development lifecycle and STLC is the software testing lifecycle. So SDLC focuses on all the members. It focuses on all members. It has different phases like requirement analysis, design document preparation, development, testing, then pre-production, then production and maintenance. And in STLC, it focuses on testing process. It has different phases like requirement analysis, where testers participate in refinement sessions and sprint planning. Then it comes to test plan, documentation, preparation, then test case development, where they write detailed test cases based on user stories, then environment setup, where they prepare the test environment, then test execution, where they execute test cases and log defects, then test cycle closure, the documents results and learning. The testing process like ad hoc, monkey, gorilla, and exploratory testing complement the overall development and testing life cycles. They ensure the stability, performance, and usability of applications, helping them succeed in real-world scenarios. Now, let's talk about test plan document. Test plan document outlines why are we testing, what will we test, how are we planning to test it, the objective of testing, the scope, entry and exit criteria, and potential obstacles. Now, the key focus areas here are test objectives. What are we trying to achieve? Scope items, features, and functionalities to be tested versus those excluded, like in scope or out of scope. Test types, smoke testing, regression testing, etc. An obstacle, identify dependencies and challenges that could affect the testing process. The test plan evolves during the development life cycle. It gets updated until system integration test is complete and stops before the user acceptance testing. Now test design. Test design happens during the development phase. When testers start writing test scenarios, test cases, test steps. In test scenarios, it describes what needs to be tested. Now, then that these details how the testing will be conducted, including steps and expected outcome on the test cases. And in test steps, specific actions taken during the testing. For example, For the search functionality, testers might discuss scenarios like filtered search, search, camera-specific search, advanced search with sorting options. These scenarios help estimate the effort required for the testing. Now, effort estimation. Effort estimation is a critical part in the planning phase. It involves identifying scenarios and estimating the time needed for the test case design and execution, identifying and estimating. Now, this step helps in creating a timeline for tasks and aligns the team's expectations. For example, if testing a search functionality, testers should discuss how many test cases needed, how much time is required to write and execute them. Effort estimations happen before the requirement session and is documented as a draft. Now, test strategy versus design. Test strategy is a high-level guideline defining testing objectives, tools, and methods. And on the other hand, test design is a more granular activity where testers define the specific test cases, steps, and scenarios. So now let's go to test environment. Test environment. A test environment or test bed ensures secure and controlled conditions for running tests. For instance, in a banking system, testers may only use secure company-provided environment to safeguard data integrity. Once a sprint concludes, all testing outcomes are documented in a test closure report. So if all features pass, they are marked as completed. So if all features pass, they are marked as completed. If they find any defects and they remain unsolved, they are noted into the defect report. Ah, now there are three types of test deliveries. One is test closure report. The other one is root cause analysis or RC. Then test metrics report. In test closure report, it documents past and failed test cases. In root cause analysis, it identifies the underlying cause of the defect. And at last, the test metric report provides a summary for testing efforts and outcomes. Now, when writing test cases, the following structure should be used, which is a template for testing. First come the module name. It defines the features being tested. Then comes requirement ID, requirement ID, which is a unique identifier for each requirement. After that comes test type, like smoke testing, regression testing, etc. Then comes priority and severity. It is determined during the predefined session. Then comes the test case ID. Test case ID. It is a unique identifier for each test case. Then comes precondition. Conditions that must be met before testing. After that, it comes to test step. Step-by-step instruction for the test. Then expected versus actual results. It ensures the outcomes align with the requirements. Then it says if the status is pass or fail. Now, use case. A use case represents a complete user story with three components. One is actor, the other one is action, and goal. Actor is the user or system performing the action. The action is performed by the actor. Then the goal is to desired outcome of the action. For example, for a search functionality, actor is the user. So for search, actor is the user. Then the action is performing a search, and the goal is to get relevant results. Okay, so to recap, today we have covered the importance of test plan, how to test design and method estimation play into planning, the relationship between STLC and SDLC, the structure and significance of test deliverables, and many more things. So we'll discuss further into the next class. If you have any question, please let me know. You can also mail me or text me. Okay. So thank you for your time, and I'll share updates soon. Have a great day. I'll see you on the next class.